everyone. We want to introduce the ellipse. Now the ellipse is the set of points on a plane where the sum of the distances to two fixed points is constant. The two fixed points I'm going to illustrate right here, and I'm going to connect them with the string. Now these two fixed points are called the foci, which is the plural of focus. Now if I said I'm going to take my string and just basically carve all the way around, by doing that, then basically every point on the ellipse, that distance will always be just the length of the string as I move all the way around and I carve this out. So now that I'm going to remove the string, if I put axes here, then the tips of the string we call the foci. We'll call C0 and negative C0 because we're going to be centered at the origin. That leads to four other fixed points here on the ellipse. Let's call this A0 and negative A0, again because of symmetry. 0B, 0, negative B. Now, if the length of the string, we notice, goes all the way across, then the length of the string must be somehow related to the A, B, and the C. So let's look at it this way. If I was here on my string, then the distance between this point and this focus plus the distance between this point and this focus must be that constant. So let's set that up. So A minus negative C, which is this distance, plus A minus C, which is this distance. If I add these up, you'll notice that gives me 2A. So that means the distance all the way across is the length of my string, or that constant amount. So next we want to see if we can establish the relationship between the A, B, and the C. Well, that's actually fairly simple to do. If I start here, then this point here is equidistant from both of the foci, and since the sum of these two lengths must be 2A, each of these individual lengths must be A. Now that creates a Pythagorean relationship between A, B, and C. So in this particular picture, the length of A would be the hypotenuse of a right triangle, or in this case here, C squared, we'd notice, would be the difference in A squared and B squared. Now that orientation will change if this thing opens vertically. Okay? Now we know that the equation of an ellipse centered at the origin has this basic form right here. And it's easy to tell. If I replace x with plus or minus a and y with 0, I easily satisfy the equation. If I replace x with 0 and then y with plus or minus b, I also satisfy the equation. Okay? And we now know the relationship between a, b, and c. Now the thing is, if I start with the equation, a tells me how many units from the center I am going to move left and right. B tells me how many units from the center I'm going to move vertically. So if B is bigger than A, then I will open it vertically. Now we already know how to shift other shapes, so what if I wanted to move the center away from 0, 0 and say some arbitrary place? So if I have here an ellipse, and let's say our center now is at H comma K, but it's, let's say, the exact same form, so the A and B are the same values, then the form of this equation, as we know, will be x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Okay? So let's just draw a couple of simple ellipses and let's see if we can figure out how to make this make sense. So if I said I've got x minus 3 quantity squared over, how about 9, plus y plus 1 quantity squared over 25, and that equals 1. Well, the first thing we need to identify is where's the center of this ellipse. So the center of this ellipse would be at the point 3 comma negative 1, x minus h, y minus k. But the 9 and the 25 are not particularly useful because I really need it in this form. So when I see 9, I really see 3 squared. When I see 25, I see 5 squared. So using that as my center, so 1, 2, 3, negative 1. Now what I'm going to do is move left and right exactly 3 units. Move up and down exactly 5 units. and then essentially connect the dots. And more or less that would be the shape of that ellipse. Okay? For convenience sake, because the roles of A and B change depending on the orientation of the ellipse, I'm going to introduce a couple of basic terms. This isn't a circle, but it acts a lot like a circle in the fact that it appears to have a radius in each direction. So if the circle opens long ways, I will call this distance the major radius, and this one the minor, and the same thing if it opens the other way. Because traditionally, the length all the way across is referred to as the major axis, but that isn't a useful number. So if I think of it in these terms right here, I can define something called eccentricity. Now, eccentricity is defined simply to be a ratio. It's the ratio of the focal length to the length of the major radius. And because of the fact that it's going to be compared to the bigger one, this is always the biggest number. E must be smaller than 1 because the focal length could never be as big as the major radius. E can be 0 in one instance. If it turns out I have a circle, then the foci are essentially at the same point, and so the value of C in that case would be 0. So if I have an ellipse, let's say, that opens this way, then my foci would be here, and my major would be here. So I just take little c over big M. If it opened this way, my foci would be basically here and here, so I'd take this distance over M. Now, there's an easy way to remember the ellipse. If I draw a vertical opening ellipse, if the foci are fairly close together, like they would be in this case here, then the eccentricity of this ellipse is fairly close to 0. But if I drew an ellipse that was very long and skinny, where the foci are really far apart, then the C would be very close to M, and so the value of the eccentricity would be very close to 1. So a very simple way to remember eccentricity, the closer your ellipse is to a circle, it's going to be closer to 0. The more long and skinny your ellipse is, the closer it is to 1. So in other words, if the shape of your ellipse looks like a 0, the eccentricity is close to 0. If the shape of your ellipse looks more like a 1, it's closer to 1. Finally, we want to actually find all the parts of an ellipse in this form: the center, the foci, the eccentricity. Now, I need to work to make this look like the form we were using before, which means I'm going to need to complete the square. So in order to do that, I will gather the terms and I will move the constant over here. In order to complete the square, I need the lead coefficient to be of the squared term to be a 1. So as I factor out the 9 and the 16, so the question is, what do I need to put in here? Well, we recognize right here this is going to be of the form x plus 3 quantity squared, so I need to put right here a 3 squared. Over here, we recognize this is going to be of the form y minus 1 quantity squared, so I'm going to need to put a 1 squared right here. But in actuality, I added 9 plus 9, so I added 81. And over here, I really added 16 times 1. So a quick check, if I distribute all the way through, I will get this, which equals this. So now we see the form here would be 9 times x plus 3 quantity squared plus 16 times y minus 1 quantity squared. And if I add those up, I get 144. So the next step is to get a 1 on the right side. So I will multiply through by 1 over 144, which will give me x plus 3 squared over 16, which I'm going to think of as 4 squared, plus y minus 1 squared over 9, which I will see as 2 squared. So now at this point here, I recognize this is going to open up horizontally because that number is larger than that number. So in order to find my focal length, I'm going to take the difference of these two, So the c squared is 4 squared minus 3 squared, or 7. So c is root 7. Finally, I can say then that the center is going to be at negative 3 comma 1. The foci, which means I'm going to move this many units from the center, but I'm going to move horizontally, so I'm going to combine them with the x-coordinate. The foci will be negative 3 plus root 7 comma 1 and negative 3 minus root 7 comma 1. And finally, the eccentricity, which is the ratio of the focal length over the major radius. In this case, the major radius would be 4, because 4 is the bigger of these two numbers. So I would be root 7 over 4. And that's about everything you need to know about an ellipse.